Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. Since you've just been introduced to the OpenAI Gym interface, we're not going to code anything too complex right away. In this lecture, we are going to add just a little bit of code to the code we just wrote to do a random search in the parameter space for a linear model. In other words, we are going to take our state S, dot it with a vector of weights W, and if this is greater than 0, we'll do one action, and if it's less than 0, we'll do the other action. Let's do a quick overview of the algorithm in pseudocode. What this does is, I'm first going to choose the number of times I want to attempt to adjust the weights. For that number of times, I'm going to generate new weights randomly. Then I'm going to play a number of episodes with these new weights. I need to try more than once, just in case an episode is really long just by chance. From this, I'll calculate the average episode length. If the average episode length for these new weights is better than my best average so far, I'll keep these weights for later. Once I've done this a number of times, I've supposedly chosen some good weights that do well over a number of episodes, so hopefully not just by chance. Then I play a final set of episodes to see how good my best weights perform. If you don't want to try this yourself first, although I highly recommend you do, the relevant file in the course repo is randomsearch.py in the subfolder cardpool. At the top here we have some basic imports, gym and numpy and matplotlib. We also have some future imports just in case you're using Python 3. If you have an old version of future, these imports may not work, so you can upgrade it by doing sudo pip install -U future. The first function here takes in the state S, a vector of weights W, and calculates the dot product. If the dot product is greater than 0, we return 1, otherwise we return 0. Next, we have a function to play one episode. It takes in the environment and a set of params. First, we reset the environment to start a new episode and set an initial value for done and t, which will keep track of the length of the episode. Next, we enter a loop. This loop is capped at 10,000 iterations because the random search can actually do pretty well. If that ends up happening, the loop is going to take a very long time or possibly never finish. One weird thing is that it seems that later versions of the gym no longer let you go past 200 iterations, but earlier versions do. To my knowledge, this hasn't been documented, so if you're using a later version of gym, then you'll automatically get the done signal when you've reached 200 iterations. Inside the loop, we increment t, choose our action, and perform the action. We're ignoring the rewards here, but they are all 1. When we're done, we return t. Notice how I've commented out this env.render function. If you call this, what will happen is a window will pop up and you'll be able to see a video of the episode as it's being played. This makes the script run much slower, of course, so we won't do it. However, you're encouraged to turn it on if you want to see what it looks like. Next, we have a function to play multiple episodes, which calls the previous function multiple times. It takes in the environment, total number of times to play, and the current params. The point of this function is to keep track of all the episode lengths for these parameters and then return the average. Next, we have the random search function. We are going to search through 100 random parameter vectors. Each are randomly selected from a uniform distribution between -1 and 1. In the loop, we call the play multiple episodes function with t equals 100 so that we test each parameter vector 100 times. We get back the average episode length for the current set of parameters, and we append this to our list of episode lengths. If this average is better than our best so far, we keep these parameters and we update the best average length. At the end, we return all the average episode lengths and the final params. In the main section, we connect to the cardpool environment, call the random search function, and then plot all the average episode lengths. Once we've done that, we play a final set of 100 episodes with the best parameters. Typically, the average length of these will be close to the best out of the average episode lengths that we plotted in the previous step. Let's run this and see what we get.